Continue with practical techniques of root cause analysis for effective problem solving. The potential of fishbone diagrams for effective problem solving. Fishbone diagrams, also called Ishikawa diagrams, show the causes of a specific problem. According to Wikipedia, Ishikawa diagrams, also called fishbone diagrams, herringbone diagrams, and cause and effect diagrams, are causal diagrams created by Kaoru Ishikawa that show the potential causes of a specific event. Typical uses of the Ishikawa diagram are product design and quality defect prevention to identify potential factors causing an overall effect. Each cause or reason for imperfection is a source of variation. Causes are usually grouped into major categories to identify and classify these sources of variation. Visualize, analyze, and solve. We can gain valuable insights into the factors contributing to the problem by utilizing fishbone diagrams and asking relevant questions. Let's explore how to perform the root cause analysis using fishbone diagrams in detail. Setting up the fishbone diagram. To begin the root cause analysis, gather a group of individuals with knowledge and experience related to the problem. Start by naming and entering the effect or problem on the right-hand side of the diagram. This effect represents the problem you are trying to analyze. Identifying categories of probable causes. Enter the key groups of probable causes on the fishbone diagram's main branches. These categories typically include people, equipment, methods, materials, measurements, processes, environment, and management. However, feel free to adapt and use category labels that are relevant to your specific situation. The purpose of these categories is to help you organize and categorize the causes effectively. Brainstorming and categorizing causes. Now, it's time to identify the causes of the problem. Encourage the group to brainstorm and ask the 5 whys to dig deeper into each cause. Note down each cause under the appropriate category on the fishbone diagram. This step allows you to gather a comprehensive list of possible causes for each category. Analyzing and eliminating irrelevant causes. Once you have listed the causes, analyzing each cause's relevance to the problem is essential. Some causes may be less likely to contribute significantly to the issue, while others may have a higher impact. Use your group's expertise and experience to evaluate and eliminate irrelevant causes from the list. This step helps narrow down the focus to the most probable root causes. Attaching and ordering possible factors. After eliminating irrelevant causes, attach and order the remaining possible factors as side branches on the fishbone diagram. These factors represent the various elements that impact the problem. Each factor can have its sub-branches to capture additional details or contributing factors. Identifying the root causes. During the analysis session, the group should identify all possible causes for the problem. The fishbone diagram identifies many possible causes for the problem. Conducting a structured analysis and brainstorming session sorts ideas into functional categories. Meanwhile, the facilitator selects the causes and ranks them according to their importance and impact. By carefully considering each cause, you can determine the most likely or predominant root causes of the problem. Asking relevant questions for root cause analysis. Asking relevant questions about each category on the fishbone diagram helps identify the root causes. Some examples of questions you can ask for each category when performing root cause analysis related to people. Was the work adequately organized? Were the documents interpreted correctly? Was the information clearly communicated? Did the receiver understand the information? Was the person tasked with the job trained to carry it out? Continue questions related to people. Was too much judgment required to perform the task? Were guidelines for decision available? Did the environment influence the actions of the individual? Are there distractions in the workplace? Is tiredness a contributing factor? How much experience does the individual have in performing this task? Is there a proper way for people to apply the plan? Is adequate training content provided? Feel free to add any other questions you consider necessary. Relevant possible questions for root cause analysis related to equipment. Was the correct equipment used? Was the correct tool used? Is the equipment affected by the environment? Is the equipment being properly maintained? Is there a preventative maintenance plan for this equipment? Is the plan always applied at the required frequencies? Is the plan's content revised periodically? A repairable part was not repaired and, therefore, was out of stock. Continue with relevant possible questions for root cause analysis related to equipment. Workers did not find enough of the required technical documents quickly. Was the machine properly programmed? Is the tooling, fixing adequate for the job? Does the machine have an adequate guard? Was the tooling used within its capabilities and limitations? Are all controls, including the emergency stop button, clearly labeled, color-coded, or size differentiated? Is the machine the proper application for the given job? Feel free to add any other questions you consider necessary. Relevant possible questions for RCA related to spare parts and materials. Is a safety material used? Was the material properly tested? Was the material substituted? Is the supplier's process defined and controlled? Were quality requirements adequate for part function? Was the material contaminated? Was the material handled properly, stored, dispensed, used and disposed of? Did workers get the required spare parts in time? Were the spares parts out of stock? Were spares the right ones? Were spares in a good state? Relevant possible questions for RCA-related environment. Is the process affected by temperature changes over a day? Is the process affected by humidity, vibration, noise, lighting, etc.? Does the process run in a controlled environment? Is the downtime affected by other environmental issues? Feel free to add any other questions you consider necessary. Relevant possible questions for RCA related to methods. Were the workers appropriately trained in the procedure? Was the canister, barrel, etc., appropriately labeled? Was the testing performed statistically significant? Have I tested for the root cause data? How many, if necessary, and approximately, phrases are found in this process? Has a capability study ever been performed for this process? Are the work instructions clearly written? Continue with questions related to methods. Are mistake-proofing devices, techniques employed? Are the work instructions complete? Is the tooling adequately designed and controlled? Is handling, packaging adequately specified? Was the process changed? Was the design changed? Are the process's critical safety features spelled out to the operator? Relevant possible questions for RCA related to the operating process. Did operators comply with the operating instructions? Are the operating instructions known, understood? Are the operating instructions applied in full? Are the operating instructions complete? Do they exist? Remember, by following the steps outlined in this chapter and asking relevant questions, you can identify the underlying causes of a problem and develop practical solutions. Adapt the fishbone diagram categories and questions to suit your situation.